Back again with Module 4 Class Notes Example 3 and another example of graphing a rational function. Once again, if you haven't viewed Example 0, my introductory video for rational functions, please go check that out. Assuming that you have that information, we'll go from there. And here, as we've done in previous examples, start the work on this rational function by factoring as much as possible. That denominator looks tempting, and we should factor that difference of squares into x plus 3 times x minus 3. The numerator is simply x, nothing more to do there. But now we've got the factored form of this function, and we can start in on the domain of this function, which once again, as we've done in previous examples, we find the domain by recognizing the denominator cannot equal 0, and then setting x plus 3 not equal to 0, and x minus 3 not equal to 0. We see x can't be negative 3 and x can't be positive 3. So we take everything from negative infinity to infinity, but exclude negative 3 and exclude positive 3 to give the interval notation form of our domain in this rational function. Moving on to intercepts, we find the x and y intercept, starting with the y intercept as we've done now in several examples, and no matter if we're looking at a rational function or any function, we find y intercepts by plugging in 0 for x. Plugging in 0 for x, we get 0 over negative 9, which is simply 0. And so 0, 0 is my y-intercept. We find x-intercepts by letting y equal 0, set the function equal to an output of 0. And as we've said in previous examples, that means we set the numerator equal to 0 when we get x equals 0, when y equals 0, or the point 0, 0. So actually 0, 0, the origin on the graph, is acting as both an x-intercept and a y-intercept for this function, which is fine, though it does mean that we're limited in the information we have. We only know one point on the graph. So we're probably going to have to come back in and fill in some more information with additional points on the graph. But let's proceed from intercepts to asymptotes, and with asymptotes, once again, we look for vertical asymptotes by focusing in on those domain restrictions, those lines that x that are function, those x values that are function will never touch, never cross, and we find x equals negative 3 and x equals positive 3. Those two equations are my equations of my vertical asymptotes for this function. Then for the horizontal asymptote, we note that the numerator has degree 1, the denominator has degree 2, the numerator degree is less than the denominator degree, and our rules that you noted from the textbook say when the numerator degree is smaller than the denominator degree, then y equals 0 is our horizontal asymptote equation. So now we've got the equations of the asymptotes, both vertical and horizontal. We've got the intercepts, intercept singular in this case, as we found. Let's plot those and see what we can see of the graph so far. Not a whole heck of a lot, but we've got the horizontal asymptote y equals 0. We've got the vertical asymptotes at negative 3 and positive 3. And we've got 1 point. So it's going to help to get a few more points here. In fact, I'd like to use 4 points to figure out what's happening, and let me outline what's happening in this section, as we've done in previous examples, and in this section. But I also kind of need to know what's going on in here and in here. Which direction are we moving? So it's good then to, well, in this particular case, it'll be very good to pick several points, as it turns out, 4 points, one in each of these sections of the graph, so that we can start to fill out the curves of the graph. And we'll do that now by plugging in an x value of 2. 2 over 2 squared minus 9, that's negative 2/5. Plugging in an x value of negative 2, that's negative 2 over negative 2 squared minus 9. That simplifies to positive 2/5. So we've got the point 2 comma negative 2/5 and negative 2 comma positive 2/5. That's going to help. And then off to the right, with x equals 4, we get 4 over 4 squared minus 9, that's 4 over 7. And way off to the left, let's use an x value of negative 4, and that's negative 4 over negative 4 squared minus 9, that's negative 4 over 7. Taking all 4 of these points and throwing them up on the graph and seeing what they tell us about the shape of the graph gives 2 comma negative 2/5, negative 2 comma positive 2/5. So those 2 points tell me that my graph is going to curve down to the from the origin. My graph is going to curve down to the right and up to the left and approach those asymptotes. And then the point 4 comma 4/7 is going to tell me that my curve, even though it's just the 1 point, I know that my curve from there is going to move toward the horizontal and vertical asymptote. Similarly, when x is negative 4, y is negative 4/7 over here. Again, my curve is going to approach both the horizontal and vertical asymptotes, and that gives me just enough information to fill out a sketch, not a perfect picture, but a good sketch of the behavior of this rational function.